Okay, question 5. f of x is x squared plus k plus 3x plus k, where k is a real constant. Find the discriminant of f of x in terms of k. Your discriminant, remember, is b squared minus 4ac. So what we need to think about is what are our a, b and c from that quadratic up there. So we've got f of x equals x squared plus k plus 3x plus k. So what would a be? A would be the coefficient of x squared, which is 1. B will be the coefficient of x. Well, what is in front of the x there? It's that bracket, isn't it, with k plus 3 in. So that is B. And C is the constant term at the end. And you're told that k is a real constant up there. So this time the number at the end is just k. So all I do is sub those things into b squared minus 4ac. So I've got k plus 3 all squared minus 4 times 1 times k. Multiply that out, I'm going to get k squared plus 6k plus 9 minus 4k. So that's going to give me, if I group them together, that and that, k squared plus 2k plus 9. So that's part A. Part B, show that the discriminant of f of x can be expressed in the form k plus a all squared plus b, where a and b are integers to be found. Hopefully you spotted that means complete the square. Okay, so remember that when we complete the square, half this number, put it in the bracket, it's going to be squared, so k plus 1 all squared, and then take away that thing squared, minus 1, and then put your plus 9 at the end. So that gives me k plus 1 all squared plus 8. Okay, so a is 1 and b is 8, if you want to think about it that way. Right, part C. Show that for all values of k, the equation f of x equals 0 has real roots. Right, if it has real roots, it means that b squared minus 4ac is greater than 0. So what that's saying is show that the discriminant must always be bigger than 0, no matter what value of k we have. Okay, well, we've already done this. We've got this for our discriminant, k plus 1 all squared plus 8. So show that for any value of k, this is bigger than 0. Okay, so you have to do a little bit of thinking. K plus 1 all squared must always be greater than or equal to 0. Okay, therefore k plus 1 all squared plus 8 must always be greater than or equal to 8. Does that make sense to everyone? So you've got k plus 1 all squared, no matter what that gives you, no matter how big the negative number is, like minus say 100, whatever it is. Minus 100 all squared will still give you a positive answer because you squared in a negative. So the smallest thing that we could ever make that equal is 0 by getting the bracket to equal 0. Getting 0 squared is 0 plus 8 is 8. So the smallest thing the discriminant can be is 8. So therefore it will always have real roots.